There is a story circulating about New Jersey. 15 drones. Stolen. Chemical spraying. FBI investigating a nightmare scenario. It sounds like a plot from a thriller film. But when you peel back the layers of the investigation, the reality is far more mundane and yet far more concerning. The narrative suggests a coordinated theft designed for a chemical attack. It implies a sophisticated threat targeting civilian populations. But forensic analysis suggests a different story. The drones in question are not military grade. They are standard agricultural units. Specifically, DJI Phantom 3 models. These machines cost around $10,000. They are designed to carry pesticide tanks over crop fields. They fly autonomously. They follow GPS waypoints. They are not built to withstand a siege. They are built to cover acres of farmland efficiently. When a thief takes one, they do not need to crack military encryption. They simply walk up and take it. This highlights a massive vulnerability in the industry. These drones operate on open protocols. They rely on GPS signals that can be spoofed. They lack hardware-level authentication. A device that costs $10,000 has less security than a modern smartphone. This gap between industrial design and threat modeling is where the danger lies. Consider the technology itself. The DJI Phantom 3 is a consumer quadcopter. It was designed for photography and agriculture. The flight controller accepts commands from a ground station. It does not verify the identity of the operator. It does not check if the device has been reported stolen. It simply executes the flight plan. If a criminal steals a fleet of these units, they can upload a new flight plan and take to the sky. The Federal Bureau of Investigation is right to investigate the potential, but the scale is likely smaller than the headlines suggest. It is not a terrorist cell. It is likely a theft ring targeting valuable electronics. The threat of repurposing is real. A chemical tank could be refilled with something more dangerous. The flight path could be altered. The drone could be flown into a restricted area. However, the threat is exaggerated by the public. Why does this spark fear? Because of how we process information. Our brains use predictive processing. When we see a drone, we do not see a machine. We see a potential threat. Ambiguous visual data is interpreted as malicious. This leads to disproportionate reactions. In November, there were mass sightings in New Jersey. Many were attributed to coordinated theft. Forensic data suggests otherwise. Most were agricultural operations. The public mind filled in the gaps with fear. This is not unique to drones. It happens with any new technology. We need to understand the psychology behind the panic. Predictive processing frameworks suggest that the brain constantly predicts what it expects to see. When the visual input is ambiguous, the brain fills in the blanks based on prior expectations. If the expectation is that drones are dangerous, the brain sees danger. This explains why routine agricultural activities are often misidentified as hostile surveillance. The media amplifies this by focusing on the worst-case scenarios. A headline about a chemical attack gets more attention than a story about a farmer spraying crops. This creates a feedback loop. The more we fear drones, the more we interpret ambiguous signals as threats. The more we interpret threats, the more we fear drones. The FBI's involvement highlights a critical gap in current security protocols. Standard detection systems often fail to distinguish between routine agricultural operations and unauthorized surveillance or hostile flights. The agency is looking at the potential for a nightmare scenario. But the reality is that the security protocols are designed for the wrong threat. They assume the threat is external. They do not account for the device itself being compromised. Future security measures must focus on hardware-level authentication and geofencing rather than just post-event forensic analysis. We need to stop treating these devices as toys and start treating them as potential weapons. This incident underscores the vulnerability of commercial UAVs to theft and repurposing. The gap between industrial design and threat modeling is the root cause. The manufacturers prioritized cost and ease of use over security. They assumed the devices would be used as intended. They did not anticipate that a stolen drone could be used for a chemical attack. This is a failure of foresight. We need to change how we design these systems. We need to build in security from the ground up. We need to ensure that a stolen device cannot be used without authorization. Until we do this, the gap remains. The nightmare scenario is real, but not in the way the headlines claim. It is a gap in our infrastructure. The drones are not inherently evil. They are tools. Like any tool, they can be used for good or harm. The danger lies in the lack of security. We need better security protocols. We need hardware-level authentication. We need geofencing that cannot be easily bypassed. We need post-event forensic analysis that is faster and more accurate. We need to stop relying on the public to identify threats. We need to rely on technology to prevent them. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.